Hello everybody, and welcome to exercise 6 on page 7 of the workbook. And this exercise would like us to find an antiderivative for x over 1 minus x dx. Okay, so I'd like to start this problem with the u substitution, u equals 1 minus x, just because u is what happens to be in our denominator. Just see where that leads us. Okay, so if we let u be 1 minus x, then take the derivative of u, we're going to get, let's see, derivative of 1 is 0, and the derivative of negative x is negative 1. Okay, and by multiplying both sides by negative 1, we get the dx by itself. Okay, so the two pieces of our substitution are going to be that and that, essentially. All right, so if we go down and rewrite our integral, let's see where this leads us. Okay, we can look at our denominator and notice that that 1 minus x is what we called u. So we're going to have x over u. And then dx, looking at our work above, is equal to negative du. So we'll make that substitution as well. Okay, now if you look at this, you'll notice that something a little unusual happens here. We've got an x sitting up in the numerator of our integral here. Does that x cancel for us? It doesn't cancel. So this is different than any of the examples that we've looked at up to this point. What do we do in this situation? In order to proceed here, we need to get rid of that x somehow. Okay, well, in a situation like this, you can, in some cases, I like to call it going fishing. We're going to go fishing for an x and see if we can figure out something to replace it with. Okay, and the place that you generally go fishing is up here with your choice of u. If u is equal to 1 minus x, notice we can take that equation and we can solve it for x. Okay, by just adding x to both sides first. That turns it into u plus x equals 1, and then subtracting u from both sides. So x is equal to 1 minus u. So we've just gone fishing and discovered that x is actually equal to 1 minus u. Okay, that means that the x that's sitting down here that we circled can be replaced by 1 minus u. It's like making a third substitution here. Okay, so I'm going to write 1 minus u for that x. And now we've taken this integral and successfully transformed it into a function that just has u's in it. All right, so I'm going to take this minus sign that's sitting out here and pull it outside of the integral. That's just a constant again. Okay, now the question is, can we find an antiderivative for that function? If you look at the list of common antiderivative formulas, you won't find that function on there. So we've got a little bit more work to do here. What we can do, though, is to do some algebra to simplify this into a form where we can actually find an antiderivative. So what I'd like to do is to take this u that's in the denominator, to move it into the numerator by making it into a u to the minus 1. You might remember this algebra technique from calculus or algebra. This can be rewritten as 1 minus u times u to the negative 1. Okay, and then think of that u to the negative 1 as something that we can distribute through that quantity. Okay, so we're going to take u to the negative 1 and multiply it by 1 and by u. And so this is algebraically equivalent to 1 times u to the negative 1, which is u to the negative 1, minus u times u to the negative 1. Okay, now algebraically, let's think about this for a minute. Remember that when we write u, that's really u to the 1. And so what we're really doing is taking u to the 1 times u to the negative 1. Let's just rewrite that, and we can simplify it at the next step. Okay, kind of a lot of algebra steps going on here. Okay, now my question to you is, what algebraically happens if you take u to the first times u to the negative 1? Okay, in that situation, because we have like bases, we need to add the exponents, so we're going to get u to the 0. And u to the 0 is actually just equal to 1. Okay, so rewriting. Okay, our function looks like that. Okay, so there's a lot of little algebra steps here, and I'm going to do one more algebra step. U to the negative 1 is 1 over u. Okay, I'm hoping that by doing that algebra, this is in a form where we can find antiderivatives. Starting with 1 over u, you might remember that we saw this integration form earlier. When you take an antiderivative of 1 over u, you get the natural log of u. Actually, the natural log of the absolute value of u. And if you integrate the constant 1, you're just going to get u. Okay, u is our variable of integration. This is an indefinite integral, so we'll put a plus c at the end. Okay, there's our antiderivative. And finally, last step is to go ahead and just plug in our u. Okay, way back at the beginning of the problem, u was equal to 1 minus x. Okay, and that would be our final answer. Or if we wanted to, we could take that minus sign and multiply it through. So a second equivalent way of writing our answer would be like this. Either way is okay for your final answer. Okay, so that was kind of a long problem. There was a lot to do here. Okay, but really illustrates the versatility of the U substitution method. Okay, sometimes you need to do a little bit of algebra and really monkey a little bit with your function, but a lot of times you can get it into a form where you can find an antiderivative.